I am going to be joined by Joel. Joel Groen is the principal product manager for Qumulo and also responsible for our cloud business. So the general manager of growing our cloud business, which is, you'll see, is a very important part of Qumulo's strategy. Joel will be doing the technical part of this presentation, walking through a demonstration of our technology, both our analytics as well as what we're doing up in the cloud. And will also help me if you guys want to ask some challenging technical questions to make sure that we can answer those properly. So I want to talk about a little bit about Qumulo as far as what the company is about, where we came from, what problems we're solving in the market. First and foremost, we're a file-based company. If you think about what's happened over the last 20, 30 years, there was a long time where there was no innovation in file. There was a lot of focus on things like object storage, the cloud. A lot of the cloud technologies really weren't focused on file systems and file-based data. And the founders of Qumulo back in 2012 saw the need for a modern file system that would solve this massive unstructured data growth. And that's really where we're focused as a company, just to give you a feel for what part of the market we're focused in. Let's see here. Of course, my computer's not wanting to advance. Okay, so we all know that file data has been growing quickly, unstructured data has been growing quickly through a lot of different use cases. Autonomous vehicles, sensor data, medical research, medical imaging, the idea of companies wanting to aggregate lots and lots of different data sources into a single pool, do machine learning, analytics to really drive their data-driven businesses. But there's been a lack of innovation in this space up until now. And the idea that this data explosion can all fit into current file-based solutions has caused an enormous amount of problems for IT administrators. IT administrators have been struggling with being able to scale their systems, being able to aggregate the systems into a single analytics engine, doing things like common tasks as you walk down a huge file system tree that used to be just a few hundred terabytes and now is many, many petabytes. Common tasks are taking days, weeks, possibly not even able to complete. All of these different problems have been the reason that some innovation has been needed in the file storage market and what the company at Qumulo is really focused on. So thinking about the history of file storage, if you look back in kind of the 1990s timeframe, this is when NetApp came out, did a great job with building out a scale-up architecture, solving a lot of the problems of direct attached storage in a rack where you could have multiple users and applications in a single rack. But there was a lot of limitations there, and these technologies, both on-premise and even as they start to put these same software technologies in the cloud, the ability to scale those file systems and to scale those architectures is extremely limited. Scale out came out in the mid-2000 timeframe, thinking technologies like Isilon started to really expand the capabilities to stream, manage lots of data into a single architecture, scale across multiple racks, scale performance and capacity independently, met a lot of the needs of the growth. A lot of the technologists at Qumulo were the founding technologists at Isilon, so we believe in a lot of what they were doing. But we also see that there's a need for something new. The idea that what we're calling scale across, where you can scale across geographies, scale across the cloud, have your file system, scale not just across racks in the data center, but across different use cases, across commodity hardware, across multiple clouds, is really what users want today, and they want it to be able to connect to their native file system applications. So Qumulo, we're a very different type of storage company. We have this guy I love. When I got off the elevator, I started at Qumulo about 2 months ago, and my boss was holding a Lego version of this guy called the Qumulo, saying, "Welcome to Qumulo," when I got off the elevator in Seattle. Super excited about our new employees, our new staff. The Qumulo is kind of a fun little icon about the business, saying he's grumpy, so we don't have to be. It's a happy culture where it's very collaborative. We want the company really working on how can we invent new ideas, how can we collaborate across departments. We use all the most modern tools for development. We're an agile development company. We use the Google Suite for sharing all of our technology across our users to ourselves. We use Slack to communicate with our users, and I'm going to talk more about that in a little bit. That when a user wants to talk with us, just like I can Slack Joel and ask him questions about our technology, our users have an open channel to do that as well. So when a user has questions about Qumulo, they have the ability to real-time talk to the engineers, the system administrators, the customer success team, a very open communication dialogue. So really, when we founded the company, we stopped and said, what problems do we need to solve as a file storage company? They went and interviewed 1,000 customers before they wrote a line of code and talked to them about, what problems do you see in managing your storage architecture? What would you really like to see from your storage company? Some of it was technology. Some of it was how they interacted with the company. Some of it was about how frequently features, bug fixes were pushed out. Some of it was about pricing models, about when they buy their software, when they buy their technology, how does that investment span into the future? And those are the different problems that Qumulo as a different type of storage company has solved, and what I'm going to spend my time talking about. And then Joel will spend his time talking about the technology and really how we do it. Just to give you a timeline, because I know not all of you are familiar with Qumulo. I mentioned we were founded back in 2012. Did those customer interviews over about the first year of the company. We're very well funded from some of the most well-known venture capital funding folks out in the Bay Area, Seattle, that type of area. We were able to take the time because of how well funded the company is and how much trust our investors had in the company to develop an architecture over the first about 5 years of the company that's really ready for production before we started to put it into production. So different from a lot of startups, different from a lot of new technology companies out there, we're not talking about the roadmap of what we're going to do a year, 2, 3 years from now. Everything that we're talking about we can do today is in production, has customer references, and is a real-time capability that we can offer to our customers. So it's kind of a fun company to work for as a marketing person, that we're not talking about roadmap. We're not talking about promises that may or may not be delivered. Everything we're talking about is something that's solving real problems for customers today. So once we came into the market, and if you think about building a new file system, I know a lot of you are very technical. It's difficult. It takes a long time to build out a really robust distributed file system, the data protection, the erasure coding, all the enterprise features that are needed for it. It usually takes about, the kind of industry term is that it takes about 7 to 10 years to have a new file system technology ready for the market. And you can see we're right in that timeline right now.
Can you say something about the money? How much get you funding?
So total right now, I think it's 245. Is that right? 245
yeah, lifetime
million.
of the company.
We have about 95 million that we raised last year in May, was when that Series D funding was closed, and 245 million in the company right now.
Yeah, neither Molly nor I are certainly not the CFO, but we're debt free, and our round in the spring puts almost 100 million in the bank. So we're using that to aggressively grow the company.
Yeah. So the company waited till we had the technology ready. We have one major OEM, which was signed back in 2017, which is HPE. We are HPE's file storage solution. They were at our sales kickoff a couple weeks ago, and they showed their entire ecosystem of all the technology they own, the technology they partner for, and the only file system solution that they have is based on Qumulo's technology. We're using them as a great path to expanding as a company. We opened up in the US, of course, first, as you would suspect. We only opened here in Europe about 8 months ago, so we're new here in Europe with installations now in Germany, France, the Nordics, Netherlands, Turkey, the UK, of course. So starting to grow here in Europe. But HPE is a great partner for us, that as we scale as a company, when we want to reach out into regions where we don't have salespeople or hardware depots, we just leverage HPE. Training is going on with HPE in Singapore next week. We have a whole team of folks out there training their APAC teams. So that's a great growth engine for us, but also a great way for us to offer really good enterprise support for new regions as we continue to staff it with Qumulo team as well. So really, you're going to see the reason you haven't heard about Qumulo a lot until now is we wanted to wait till we were running in the cloud, running with enterprise features, running with install base customers that are evangelizing how they're leveraging Qumulo, and then really start to push the marketing engine. So with that last round of $95 million that the company got, it's all about sales and marketing growth this year. And so that's why we're here with Fred too.
I got a question because more and more even analysts compare your solution, which is a NAS, scale across that, with object storage. And the first time I met Qumulo, in fact, you were it was Mr. Goldblum, I remember, CTO.
Peter Godman.
Yeah. And he explained the main difference between Qumulo and the object storage solution. Today, how do you manage to be compared to the solution, and what today you can keep the differentiators that you have against Scality and so on?
Sure. We'll talk about that a little bit now, and then I think it'll become more clear as we talk through the technology, but I definitely I'll tell you my perspective. Joel will probably add to it. One of the things that a founding tenet that we had as a company is that if you think back about a decade ago, and I've been in the file storage space for a long time, we were starting to think that object storage was going to be necessary because file systems were reaching their limits on the number of files, the amount of performance, how you would handle metadata for all those files, and that something like object storage was necessary to solve that problem. Qumulo looked at it and said, no, we do need to solve those problems, but applications that are out there are primarily file-based, especially performance applications, and forcing all those applications that have been written over the last 40 years to switch to a different type of technology isn't practical. So let's solve the problems of the file system. So what Qumulo did is re-architected so you wouldn't have limits on small file performance, the capability of solving small files, storing lots of files, and still being able to assign searchable metadata to them. So we solved that problem. And then separate from that, as you start to look at our architecture and you want to add low-cost capacity, whether you're doing it on-premise or you're doing that low-cost capacity in the cloud, you still get the economics of scale that you would get with an object store. So for Qumulo, we feel applications want to talk file. We do have the capability to write to RESTful interfaces, but that's not generally what our customers want. And then we have to offer the distribution and scale of an object store, which we compete against all the time and are easily able to do within a file system. So really, why add an object store is the premise of how the company thinks. Do you want to add to that at all?
Yeah, I guess the only thing I would add is from a cloud perspective, you're seeing file and object kind of coming together. And at the end of the day, we care about what our customers care about. And so in the world of unstructured data, whether those are files or objects, a customer just wants to do work with that data. So if they want to do work with that data, we should allow them to do the work in the way that they want to do it, using the applications that they choose. So as we get a little deeper into this, we'll talk about how, especially in the cloud, we're building a file system that integrates seamlessly with an object store over an S3 or whatever protocol that cloud service provider offers, and allows you to access data.
S3 API?
Today, our S3 API is through MinIO, if you know who they are. We have a partnership with them, and we're also building our own native to add on to that. But more importantly is, so that's the application access to the file system. If you think about a Qumulo cluster running, we'll use AWS as an example, there's what we're working on right now is the ability to have S3 bucket sitting next to the file system and move that data back and forth. There are obviously times where you want that data living in S3, and there are other times that you want that data living in file, and there's no reason a customer shouldn't be able to manage that in the way that works best for their workloads.
You say you're working on that. What's your estimate and when it'll be out?
The first version of that will be out next month. And it's as we can get into a lot of how Qumulo develops software, but we're very iterative. It'll be the very first version of it. It won't be fully featured, but we'll provide the very beginnings of being able to read. For example, the very first thing you'll be able to do is read an S3 object through the file system. So you can come in over NFS or SMB and actually read through the file system to an object. And then over time, you'll be able to write to that object, move them back and forth seamlessly, create policies for where you want those, where you want that unstructured data to live given the workload that you're working on.
So can you tell us what sort of challenges you're facing in trying to do that with S3?
Well, there's a couple challenges. Obviously, object stores by definition are eventually consistent. File systems are immediately consistent. So you have to meld those two worlds for an application that is looking for data. So there are some challenges there. And then just we believe, because our customers have told us loud and clear, that when an object is living in, and again, I'm just using AWS as one example, in an S3 bucket, that needs to be native to the AWS ecosystem so that you can access that object over S3. So we're not putting anything into that object that wouldn't allow it to live as a native S3 object. So that an application could maybe come in over S3 and access that data over S3 directly into the object. And if you move it in the file system, you should be able to come and get it over NFS, and it should be the exact same. So we have a one-to-one mapping of files to objects. You trade off in those cases some economics and even some performance at times. So we're working through all of those challenges.
Okay, that's great. Thank you.
Yep.
I was going to ask something similar on the challenge you face going forward. You mentioned HPE, and the architecture is moving much more towards an intelligent edge architecture where the loading is much more towards the edge. How does that affect the play that you do? I know you mentioned one-to-one mapping and the latency, but in effect, can you move more and more towards the edge? Can you load balance IoT data, etc.?
Sure. So the powerful thing of Qumulo, and I don't want to get us too far off of the agenda, but is that we are a Linux application that runs in user space, which gives us great power and flexibility to run on a variety of platforms, whether those be big iron systems that run in the data center or small systems that run in autonomous vehicles and are collecting data and then figure out a way to home that data back to some other system, or run in create very, very small clusters in regions all over the planet in a cloud service provider. So because of that flexibility, we can work with whoever platform vendor is our customer's choice to enable whatever workloads that they want to run.
Yeah, and I think it's important that HPE is an OEM. That's not our only go-to-market. It's just a way we're accomplishing some scale. But I think as you go through today, it's a really good question. One of the great benefits of the way Qumulo is architected is we are software defined. You can deploy small instances in the cloud, on the edge. We're not limited to like a big central file system. So that's definitely a good way to think about how you can deploy the Qumulo technology. As a software-defined solution, when we talk about that, it's that you have the same file system no matter where it's deployed. If it's in an instance in AWS or GCP or on our hardware, the user's experience is it's the exact same file system capability, the same licensing structure, everything's identical. So it gives a lot of flexibility for those types of environments. We already talked about HPE, and so I'm going to jump on to kind of the use cases to help you frame how Qumulo is deployed today. We focus it, essentially you can think about when we talk on a product management perspective, we talk about high performance use cases that are split into streaming performance and small file performance or IOPS performance. So I don't have that specifically called out on this slide, but we always talk about how do we maintain this performance on 4K video and media and entertainment, but also on having small files and lots of small files coming off of corporate IT, rendering farms, things like that. So that's always a focus for us on the performance side. And in those cases, often customers are using all-flash solutions. Many still use a hybrid solution because our architecture is designed that everything is written to flash first. We cache it and then push it down to hard drives. So even in these very high performance use cases, we don't force our customers that they have to use flash or NVMe to get the performance. If they want to push it down to hard drives for capacity, they can do that. Talking about what that means competitively when you think of a company like Weka.io, who they have NVMe architecture, and as you push it out to S3 for capacity, you have huge performance hits on the S3 side. Or with the Qumulo architecture, you can get economies of capacity in a little bit more of a traditional hybrid type of solution. Mixed use, these are environments where they have the requirements of some performance, but then they also retain a lot of data for analytics typically, either for analytics for things like autonomous vehicles who are doing research and development, or corporate file shares where you're just retaining the data on the same solution that you're using for your business units. One of the quotes that I love from one of our customers who came to sales kickoff a few weeks ago was that he can use Qumulo for both his business data as well as his research data, because he can get better business intelligence by the analytics of a shared system. And so that's something that you see because of our architecture being able to handle different application types very well. And then capacity optimized. There's the markets that have massive thinking video surveillance use cases, where they're pulling in a ton of video. They save it for a long time until there's an incident where they need to be able to retrieve some and be able to have that very well protected, whether it's through erasure coding, snapshots, typically not replication and surveillance, but in other areas it is. We have it built, you can have very cost optimized with built-in data protection without having to bring in third-party applications. So this is really the advantage of Qumulo. I'm going to talk through each of these 6 topics here in just a minute, but the idea that you can scale across, we see cloud as a key tenet of the company. Cloud being both the processing, not thinking just storage. We use cloud compute, bursting compute in a lot of our customer environments today, where they want to go and take advantage of a 1,000-node render farm, but then store the content on premise. But we also see customers that find us in the public cloud. They go up to the Amazon marketplace, they're looking for file storage solutions, find us in the marketplace, run up instances, and we don't even know they're using the Qumulo technology until they call someday with an on-premise need or a customer support need. So cloud is a core tenet of our architecture. We want to help customers get to the cloud. When you think about the sales pitch from a lot of vendors, and I've worked for vendors that this is the pitch, that you say, yeah, we can architect the cloud. That's absolutely something we can do. But they aren't incented to do it because they have such a huge business infrastructure around selling hardware, maintenance contracts that support hardware, upgrades of disk drives, those types of things, that the sales reps really can't make their quotas if they're not focusing on-premise. Where with Qumulo, we want to help our customers get to the cloud. The entire company is designed around, maybe you have a cloud initiative today and we're going to help you with it, or you think you will have one 3 years from now, and you have an architecture, a licensing structure that will scale to the cloud at that point. That's really important to what we're doing. And then certainly being able to take advantage of both burst compute and storage in the cloud. So I'm going to walk through these differentiators now. So the first part that we focused on is building a new modern enterprise file system. One of the core tenets of the company, as I mentioned, is file data is here to stay, but we need to be able to scale, we need to be able to data protect, we need to be able to integrate the cloud, and we need to be able to offer to our customers real-time data analytics so they can know what's going on with their system, who's using the data, what data they have, and be able to do that all real time. So as you look at our distributed file system, we are all designed on commodity hardware. You can buy,
At this point, specifically, how do you avoid the product that have no the hyper-converged environment to have always, when you want to scale, to have a problem? Maybe more needs in storage and not in compute, or more in compute and less in storage and capacity. Mm-hmm. How do you manage to avoid this steps level in the manage if you grow up, if you scale out symmetrically at the same time performance and capacity?
Yeah, so again, I'll start, Joel may want to add to this, that the idea is we have a variety of different types of nodes that we support, that some are much more compute intensive, some are much more capacity intensive. And so if you look at our whole hardware support matrix, there's a variety depending on what kind of workload you have. So what our customers will figure out is what is their ratio of capacity to performance they need. and then they scale that way.
Well, that means
but it's different for different workworkloads.
but it
Absolutely.
means that I can scale out in my cluster with maybe just a 2-core new VM and more capacity in storage, and you have multi-configuration of this kind of
so we have,
to add in the cluster. This is not a purely VR 4-core 10 terabytes VM that I had in the cluster.
right. It's all
Okay.
designed workload specific, and we help them with what that should look like. What is nice about this is because of this architecture, when you add it in, it's all super easy. Real-time load balances, integrates it in the environment without any administrative work to take advantage of the new performance and capacity, which is super helpful to them.
So does that mean you have specific nodes that are pre-configured, or does the customer really modularize it himself?
No,
So-
we pre-configure, and it can be bought from us or from Dell or HP. So we have lots of options, but we tell them here's the reference architecture of if you want, because we do need to make sure that they're going to have sufficient memory, sufficient SSDs for our caching, the right amount of processing power. So we tell them for these different pre-configured nodes, which you can buy from someone else or from us, this is the configuration you need if you have a demand for a certain number of IOPS or a certain amount of
Maybe you
capacity.
can have some details on the nodes later. Yes.
We can.
Sure.
Absolutely. Yeah.
Yeah, the only thing that I would just quickly add to this conversation is in the architecture that Molly just described, there is somewhat of a linear growth of capacity and performance. However, when you move into the public cloud, you can separate those and you can grow capacity and performance independent of one another. If you want to leave your performance exactly the same and add more capacity, that's very easily done, and vice versa. If you just need to have a much faster cluster for a specific workload for 3 or 4 days, you can create that while leaving the capacity as is. So that is one of the advantages, obviously, of living in a giant virtualized world like the public cloud.
So no matter what kind of instance you need in the cloud, so you can really specify more modular than even.
Correct. You could, we use the same underlying architecture, but the ability to mix and match to basically build you the cluster that you need based on a very specific workload and leave that underlying data set as is and just change the compute and capacity is perfectly, is one of those things that we support in the cloud.
So you just mentioned Dell there. Does Dell the people negotiating for your own clients, or they're not OEM?
Yeah, so essentially this is more the environment where they're a big supplier of hardware. And if customers want to be able to go to Dell, they can buy from Dell. We have certified solutions. We have, configurations that work well for them. They're not an OEM in any way. It's simply just buy the software from Qumulo, buy your hardware from Dell, and they marry up on site. We see a lot more success with HPE because they're pushing the file system. But customers like the flexibility, and still a lot of customers want to buy a pre-configured appliance from Qumulo, which when we do that, we really just pass through the hardware cost to the customer with a bit of markup to cover supply chain. But that's not, our business is all designed around selling software. But we try to make the buying vehicles easy for the customer, whether it's hardware or it's up in a marketplace in the cloud, where you can just buy it directly up on the cloud. This real-time no tree walks piece is really important to the differentiation of Qumulo. The idea is we have a real-time data aware file system. As data is ingested into our system, we create the metadata, the searchability that if an administrator wants to do an upgrade on their system, if they have a failed drive in their system, or if they want to ask questions about they ran out of performance overnight and they're not delivering on the SLAs to a single user, what is causing the problems within the system? All of that is real-time analytics that's built into Qumulo. It's not a third-party package. It's actually a part of our file system architecture, which Joel will talk about later when he does the technical portion. But if you think about lots of unstructured data, lots of different applications using a single system, and being able to have that insight into your data is an absolutely core piece of what customers need from a modern file system, and one of the biggest differentiators we have versus any of the file system technologies that were built 10, 20, 30 years ago, and a big reason why customers come to Qumulo. And then, of course, we have a full suite of just enterprise features, quotas, replication, snapshots, all the things that a customer would expect from an enterprise file system, just from a data protection, data copy perspective. That's all built in and very robust and available in systems today. As far as efficiency, this is that customer video. I actually pulled this quote from that. But the idea of when you buy a Qumulo file system, you can use 100% of the file system is a huge differentiator. If you think about most solutions out there today, 85% of the storage can be used. The other 15 to 20% is either for administrative tasks, or if you start to use it, the performance degradation is significant. We design and recommend to our customers that they use 100% of their capacity. Of course, if they hit 100%, they run into problems, so we do recommend they're careful about that. But there's no performance degradation as you get to 100% usable storage that you've purchased. We also have a very efficient erasure coding schema so that you get a great raw to usable capacity, and we handle small files very well. If you look at systems out there in the scale-out space, typically it takes about 5x the storage of what your actual small files are, the size of your small files, to be able to protect them in the erasure coding schemas that are built into those environments. We handle them very efficiently. In general, you find if you add all of this up, depending on the workload, the mix of files, you get about 30% more storage that you actually get used for Qumulo for every petabyte you buy versus an alternative out there. So there's just a huge financial difference. This is 10x, which is unusual, but it's a real customer case. Usually it's about 30% more.
You say there's no performance degradation. How do you know that?
So I will let Joel speak to that. And I'm going to put up a slide here just to give you a visual while Joel talks about that. This came out of Dell World a couple weeks ago. It's one of their publicly available presentations. What you're seeing here, and I know this is small, is this is 80% of your storage capacity. What they recommended to their users and their SEs is, at that point, you start to have capacity versus performance trade-offs. You might have system reliability issues, and once you get up around 90%, the system won't function properly. So you're in the red zone, don't do that. If you look at a Qumulo cluster, and I watched this on an SE Slack channel, this is where I found this content. They saw this and said, that's interesting. We're going to go to Qumulo Trends, which is a cloud-based environment where we have access to see all of our customers' clusters. If they give us access to it, we don't see their data, but we can see how it's performing. We can see what kind of nodes they're using, what kind of I/O they're pushing. What you're seeing here, and you'll have a copy of this presentation, is this is 100% capacity usage. Over a 3-month period, the customer's been running very, very close to it. We've never had a support ticket opened. We haven't had any issues with performance. They've been running on average at 98.1% capacity, and we're happy for them to do that. So it just gives you a feel for the real world case of this. I think it's fair for Joel to talk about how and why we are able to do that.
Is that actually being used or simply allocated?
Oh, no, this is production usage.
And they often get confused.
No, this is production usage, and that's why you're seeing it bumping around, is as they're working in their environment, it's going up and down right now.
Yeah, you are not the only one software-defined storage app on the market. So what makes the difference inside your software? It's the way you manage the metadata that makes you capable to do such kind of things.
So all of these are differentiators. Software defined to us is just a thing. It's the fact that we don't tie to a specific hardware, that from a licensing perspective, you can move across different hardware architectures. But all of these different pieces are Qumulo differentiators versus different technologies that are out there. So this is versus other file system architectures. The software defined is such a broad comment. All these 6 differentiators we're talking through are where Qumulo differentiates, though. But I wanted to make sure Joel got a chance to answer why we don't need that 15 to 20% where other technologies do, because I think it's an important architectural point, and he can speak to it better than I can.
I was thinking about how to answer that, and honestly, where I land is, why not? Why? I mean, I've never worked for Isilon, so I can't tell you the technical underlying architectural reason why at 90% they start to fall over. There's no computer science reason why an application that's running in an x86 environment shouldn't be able to run regardless of how full the drives are. So I don't have a great reason to tell you why we can. I'm more. You may all know better than I why they can't.
You are talking about the usable storage, so maybe the total storage. It depends how do you reserve the space. Maybe you reserve some type of space, other not, and use the free space for the building or other type of.
There's a degree of virtualization layer.
Maybe.
In fact,
No, we're actually
it's
talking
very
about purchase
optimistic.
capacity, though.
It's very optimistic when they say 80%.
It is.
That's really the limit. In fact, more or less, they are using only between 40 and 50% of that, because after, when you have too much data, you have to swap to the disk, and you've got very big impact on the performance.
And that's why
Every
this
time.
user says he actually could only use 10 terabytes of what he purchased. So
But
there's a lot of ways you can do the math
Yeah.
on how you allocate, how
But
you erase your
I've got
code, how you
another
handle small files.
question on that. Every time in the cache, you have to recalculate to have this optimization on the disk.
Sorry?
In the cache, you have to the algo recalculate to have this kind of optimization in the cluster every time you add data and so on.
This is all calculated in real time.
Yeah, but the algo work in the cache when the data are written down in the cache to allocate after the optimization in the cluster.
Yeah, so any write that comes into the cluster lands on SSDs, and we have, so we don't write to NVRAM, we write into a huge, in the case of a large cluster, multi-terabyte SSD flash cache. And then we can make decisions over time as that cache fills about how to lay that data out on disk and expire it down. We make decisions based on some of the logic that we've built in the heat maps that we've built into the cluster to make decisions about which of your data should live in cache and which should live on spinning disk. And we have prefetch algorithms that when you start reading out of a directory or a very large file, we'll go grab the rest of that directory or the end of that file and start loading it back up into SSD to try and optimize the amount of times that you're actually reading from flash.
That's the point that I wanted to understand.
That is to say that in fact it's good, it's good the performance for you or good capacity usage, because all the data just come on the SSD part first before going
correct.
to the storage. And that at this moment that the decision is making to push it in the right place.
Right.
That's right.
Okay.
And we do things to package up small files and put them in sets down to the disk. There's a lot that happens in our cache that helps to maintain that.
Yeah, and we can go deeper into this topic in a little bit if that's an area of interest. Certainly happy to talk about how that efficiency works.
So when we talk about performance, it's really important that we are managing both small and large files in a very efficient way. When we talk about this claim of highest performance file system in the cloud, you have to think, the way we think about it is, and we have this cost matrix that our cloud team has built out, one of Grant's team members built out of, when you put, let's say, Weka, ourselves, NetApp, used Amazon's file systems, how much resource does it take to get performance? So we've tried to do an apples to apples comparison of what kind of resource are you using? Is it NVMe? Is it SSD? How much processing? How much memory do you need to get your performance? And when you look at the performance of Qumulo, and if any of you want to see this, I'd be happy to share it. For the price performance, we're about 1/10 of the cost of Weka. They certainly can go extremely fast. We can too, but they use a lot more resource to do it. It's a lot more expensive to do it. Qumulo is very efficient in how we use these resources. So when we talk about high performance in the cloud, we're talking about on a price performance basis, the cost per performance, how efficiently we can do that. And then you can scale it, to whatever you want to scale it to within the cloud infrastructure. We already talked about the flash first architecture, that everything lands on flash first. That scales, that's how we do everything real time also. And our ability to handle both small and large files, mixed I/O, is a huge differentiator in our customers being able to use different applications with us. The idea of storing and processing anywhere, that we were, from the very beginning, the technology was designed for the cloud. So when we wrote this architecture, it was in the world where cloud was a significant influence in our customers' sites. We designed our architecture that can run in an instance in the cloud just as easily as it can run on on-premise hardware. So the technology wasn't ported to the cloud. It wasn't an afterthought. It was designed always to run with the cloud in mind. What that means for our customers is as they start to make a shift to the cloud, or if they're just bursting to the cloud, it's the same file system, it's the same technology, it's the same analytics that they got when they were working on premise. And kind of conversely, the customers, we have a big oil and gas customer who runs this primarily in the cloud, but they're now thinking about maybe they'll use this on premise. It's the same technology and file system that they're using up in the cloud today. When they shift to the cloud, there's no application modification, no user changes. It really is this exact same file system and architecture. Our customers really find that Qumulo is their partner in helping them with digital transformation. You'll hear this over and over again if you ever read Pure Insights on Gartner or have the opportunity to talk to our customers directly, that they say, what I love about Qumulo is they're really my business partner that's helping to get me to the cloud. They're my business partner who's figuring out, how do I get my applications up there? What are the obstacles I need to go through to successfully migrate workloads? What do I need to keep on premise for the right performance attributes? But that's our entire business, is helping our customers accomplish these initiatives. A lot of customers buy us today on premise, put a couple petabytes of us on premise, but know that when they do shift to the cloud, the licenses they bought, the software licenses they bought from us, they can shift those up to the cloud without having to buy any new technology. So we help them have that investment protection as well as the same software technology. When they make that change, they don't have to go and buy all new software licenses. They don't have to reinvest to make that change, along with the technologies being so seamless.
So when you mention digital transformation, a lot of the functionality is changing. A lot of the processes are changing. It's becoming very much large-scale data, personalized to certain people, and scalable quite drastically. Mm-hmm. There's a lot of different types of data coming in for that as well. Does this work for particular types of data? Is it tuned to enhance that?
Where we're focused on, of course, is file data, which I've made clear. Yeah. But beyond that, it's really not, we have...
Sorry, I meant in terms of distribution. So,
So we really work with our customers. We have great calculators and tools and benchmarks and all those things that we understand the customer's workload. And if they're using on-premise types of nodes, making sure we recommend sufficient cache for a workload. If it's going to be very read-write intensive, very active data, lots of small files, we'll recommend more cache. If the customer needs a lot more processing power, if they have a lot of throughput, we have different architectures for that. So our file system is extremely flexible. It's kind of the implementation of what kinds of resources in the cloud or on-premise we recommend for the workload, and making sure that they'll be able to achieve the performance they want and those types of things. But it's not a file system limitation. It's just making sure you have the right resources underneath it that all the time really goes into. But no, we're not really optimized for a specific type of workload. We do streaming through performance very well. We do small file performance very well. It's more, like I said, the resources you allocate to the file system. And then the idea of archive, this is new. We actually haven't announced this yet, but we're just coming out with the capability to push content out of our file system out into an S3 target. Today, for archive and active archive, we have active archive nodes, and you asked earlier, I'm happy to share with you what our different nodes are. But we have archive optimized nodes that have a significant amount of capacity, resources to have good throughput. But we have hardware configurations for archive today that are part of the Qumulo cluster, and the ability to export to S3 is something that's coming out here imminently.
Do you will have a kind of tiering, because S3 is quite efficient, but for really cold data, I think send it to Glacier or something ready to
So for our
stay for a very long time in the cloud.
Yeah, so the way the architecture is designed today, and if you look at our customers, you get such efficient storage economics, just cost of capacity, cost of performance within the cluster, that they tend to not want to put tiering in place. And I will talk about tiering, but just kind of stay with me for this idea.
I can't afford F3.
Yeah, so the idea is, what we find from a real use case is, if they don't have to tier, they don't want to, because that's complicated, it's expensive, adding in HSM type packages, or the overhead of doing it within the system. So in general, our customers say, if you can give me the economics I need in the cluster, that's what I want. But we also do have demand, and customers ask about it, of being able to use the cloud as an archive tier. So when we do that, it's less of a tiering, but more that we'll export and be able to leverage just as another pool of storage, the S3 technology. And I only get into the subtleties of tiering because tiering sometimes means things like different policies, you're pulling it out of the system, you have to ingest back in a certain way. What we want to implement that is that S3 is just a way to extend our cluster. It's a one-to-one object mapping of files to objects, so you don't have to come back through the cluster necessarily to access that data. That's the vision of it long term, is it's a more dynamic use instead of traditional HSM. But yes, we absolutely see our customers have the need to have low cost economies of scale. There are customers up in the cloud who want to be able to use S3 for their long-term storage. Our initial implementation will be that Amazon moves it to Glacier versus us doing it. So we're thinking about those things. From a real-world adoption, there's not a lot of need for it just because our architecture is efficient and they can keep it in their primary storage, honestly. And that goes back to the question earlier of us versus object store. We have very efficient cost per capacity storage in the cluster. We compete against object storage on economics often and win. You don't need to get it off into an object store to have cost-effective archives. So it's just a different way of thinking about it, that these architectures in the file storage space are now so efficient. Tiering and those things aren't as necessary. There are still reasons to do it for sure, but it's not the primary driver that we have right now. Is there anything else you'd add to that?
I don't think so.
Okay.
How about Azure logs?
Yes, not today, but yes. Today we are live in AWS. We have customers running us in GCP, although not yet announced or in production, and Azure by sometime in 2019, yet to be announced when that will be.
Thank you.
Yep.
It's 100% customer driven. We're just seeing where our customers need us and where they're deploying us and driving it that way. Software defined. So kind of just talking about what software defined means to us. That's a overused, confused term. What it means to Qumulo is our company's business model is designed around selling software. That's what we would love to be 100% software company and ideally not do hardware at all. So if you just think about kind of the tenets of our business model, we do sell hardware because customers want single source, they want a pre-built appliance. We do that for them, but we're not building our business or our revenue growth models around needing to sell hardware. We also have it built around when you buy software from Qumulo, we're trying to have a variety of different types of reference architectures, certified solutions that wherever a customer wants to procure, we've certified with one of them. The idea of our software licensing model, if you buy today on premise, a petabyte, let's say, of software capabilities, and next year you want to move 500 of that to the cloud or to a different hardware vendor. Maybe you end of life your Dell hardware and you're going to HPE. You can move your software with that without having to rebuy your storage capacity. So when we're talking about software defined, that's what we mean by it. We also have the cloud as part of that we feel like the cloud should just be handled as yet another processing and storage target. And from our customer perspective, they see that as investment protection. They see it as a way they don't get locked into a configuration they buy today. If they need to make a change later, they have to repurchase everything. There's a lot of pieces they see that that's just a dynamic partner that is helping them to leverage their investments properly. On the visibility to your data side, we already talked about this some. When Qumulo first came out of stealth mode and started talking, this was probably the biggest differentiator that people were seeing as something that Qumulo was a company to watch out for. It's very, very hard to add in real-time analytics to older technologies. Many of you know companies I've worked for. I've worked with parallel file systems a lot in my career. The idea of adding real-time analytics into a parallel file system architecture where you have metadata controllers, storage, different types of nodes for the application, the file system to live within, it's impossible actually to add. I've worked on teams on GPFS, StoreNext, technologies like that wanted to compete on this, and architecturally it's just impossible. So they do things like third-party applications sitting in front of the storage, maybe sitting, in band or out of band, trying to create this information. It's an add-on, it's not integrated, it's more expensive, it can have performance impacts. Lots of issues that if you don't build this from the ground up into your system, it's very difficult. And for these huge environments, huge capacity environments, our system administrators, as well as our business managers, see it as critical. Business managers use it for things like chargeback to departments on usage. They use it to identify when they're going to need to add more capacity. So part of our Qumulo trends that we had talked about earlier that shows information about the cluster, it will predict when you're going to need to add capacity, when you're going to need to add performance in the future. They can use that for budgeting purposes. From an administrator perspective, it's things like finding where you have bottlenecks in the system, capacity limitations in the system, issues within the system. And in these huge systems, that's a big deal. It can be really tough to track down when you have, many nodes, many locations where you're having issues within the system. This helps you to ask that question and get real-time feedback instead of spending days trying to troll through logs and things like that. And then from an API perspective, we have really embraced the idea that you should be able to make your system automated. The data is growing quickly. We want to have real-time insights into your data. And if you want to be able to provision storage, do common tasks over an API, automate it, we're investing in making sure that our users are aware of our GitHub community and share contributions within that community. Designing this programmable infrastructure so you have a NAS environment that really can be run across a custom API, push information to existing packages, whether it's OpenView or something like that, you can do that. But we're really embracing the idea that machine-generated data is growing so quickly in the world that you kind of need machines to manage that data. You have to automate, you have to use applications to do that, and we're embracing that within the Qumulo technology as well. And then lastly, this customer success experience. This is as important, if not maybe more important, than any of the technology things that we're doing, that our customers love working with us. You don't hear that much. Customers don't tend to love their storage vendors. They're kind of a necessary evil. When there's going to be a problem, and when there's going to be an escalation, when there's going to be a question, the storage administrators kind of gnash their teeth and go, oh God, I have to open a support ticket. We don't want that to be the experience with Qumulo. We're extremely invested in where our customers really like working with us, and they do like working with us. Like I said, we have Slack channels open to every single customer. Anybody at Qumulo can log in and watch what's happening on those Slack channels. So our CEO, if he's interested in what's going on and what the communication is with our customer success team, can and does log into those channels and watch what's going on. Product managers, engineers, all can watch what's going on and also answer questions. When they ask a question, there's nothing like, what's your support, what's your serial number, what's your support contract number? None of those questions are ever asked when they call into Qumulo. We answer the questions. They're always answered with, how else can I help you? Sometimes that's, network configuration, performance optimizations. That's real time and always available to them.
These channels are not limited to a specific customer. They're open to all customers.
They have dedicated Slack channels.
One for each customer.
Yeah, so that's private.
We have one public customer channel that anybody who wants to jump in there, any customer can go in
kind of like
post
a community.
question.
Yeah.
But every customer has their own dedicated channel.
This idea of we hear you, we agree, it takes a little explaining, but it's kind of cool. You'll hear, if you ever talk to our CEO, he says it a lot, that whole idea of a customer says, you know, I just hate this about my storage vendor. I hate the way my support tickets are open. I hate the finger pointing. I hate that my licenses can't transfer to a new hardware platform. Whatever that is, instead of us saying, read the fine print, this is the way the company was designed, our response is, we hear you, we agree. We're going to figure out how to make this the way it should be.
Don't limit that to storage.
And it's you know, we've read books. There's areas from other industries where they've embraced this type of customer success model that's not in the IT space. We haven't invented the idea. We've watched it be extremely successful in other industries in the world. Our customers absolutely, 100% literally, say this is one of the reasons that they buy Qumulo. I'll talk a little bit more about that just before I hand this off to Joel. So that's kind of the differentiators on our software side. On the platform side, I'm happy to give you what these node configurations are, but this is how we think about the storage nodes within the Qumulo architecture. We have all flash, designed for, obviously, performance, particularly IOPS performance. I have some specifications here as you go from 4 to 50 nodes, kind of the scale on capacity and scale performance that you get on those all-flash nodes. We have mixed use, where this is where the data hits SSD first, as we were talking about, and then scales down, or is then moved down to spinning disk for the longer-term retention. And then, as I said, we have archive nodes designed for active archive. They're active within the cluster. There's no tiering that's happening here. It's just active archive nodes within the Qumulo file system that are optimized for performance, optimized for that. Optimized for capacity, optimized for long-term retention. We have these building blocks from Qumulo, from HPE, from Dell, and reference architectures for each of them. And within these, there's more model numbers, that some are more capacity, have more cache, or have more processing power. So depending on the workload, there's often multiple model numbers within here. All this designed around being customized to the workload. As we were talking about earlier, workloads are different, types of I/O patterns are different. So we have a lot of flexibility within these tiers of which types of nodes we recommend. And then within the cloud, it's very flexible. The types of instances you buy, the types of performance you buy, that's extremely configurable for whatever a customer needs. So we see kind of this is an enabler to our file system, but no matter which nodes you're using, which performance attributes you need, is the same file system and the same feature set for all of them.
And what sort of proportion storage do you find your users prefer to commit to flash?
So, do you know?
I don't know the exact numbers.
Yeah, I have a pretty good feel. The last numbers I've looked at, the majority of our deployments are here.
Absolutely.
Because everything hits flash, and then you get the economics of hard drives. Of course, flash costs are coming down and all those things. But the types of flash you use, is it consumer grade or not? There's a lot of things in the hardware you can get into with that. What we find our customers buying is a reasonable amount of SSD cache here and hybrid units. That's still the majority of what we sell. Right. On this side, you have some people who just love flash. They say, I'm only going to have flash data center. That's fine. Sometimes they're buying for that reason more than because of the cost or the performance dynamics. We do have NVMe nodes. There's some places where we find NVMe really helps in certain types of workloads. But I think, don't write these numbers down, but probably about 80% is these hybrid. And then there's 10%, it's something like that.
I would say that was true 6 months ago. We announced an active archive node last summer.
It's been about 7 months.
Yeah, and it's really taken off. And so I'd say that mix of
it will change
within this has changed over time. And we've had a bunch of really, really large. If you're looking at it in terms of node count, I'd say the 10-80-10 is probably pretty close. But if you're looking at capacity, because these are so dense, there's been a lot of, especially in video surveillance and some of those other workloads where there's just lots and lots of data, that's really taken off for us in the last 2 quarters.
So before you hand it off, I got two questions for you, Molly. First one, you mentioned licensing. How is your software licensed?
It's licensed on capacity.
Okay.
And we have it designed, there are two price models based on performance versus archive pricing, but it's all based on capacity.
It's a subscription model.
Subscription, I should mention that, yeah.
Oh, so you're paying annually or monthly or something for a certain amount of terabytes?
It's an annual charge. A lot of our customers will buy 3 to 5 years at a time, and they get a discount if they do that. We are just at that point where a lot of our customers are at that renewal point, where they've bought 2-3 years now, and they're starting to renew, and we're finding that renewals are occurring pretty regularly, as you would expect.
So if you're charging by capacity, are those charges tiered along with the type of capacity that the data is being held on?
Right now, there's the performance and then the archive pricing, and you can shift that. So there's just two tiers.
Okay.
Mm-hmm.
Final question for you.
And it may change. I mean, as we're looking at things like S3 or Days on Glacier, we're still contemplating exactly what that looks like.
And one really, really important thing about our subscription model is it is an all-in subscription. That includes software support. That includes the roadmap. So as we release new features, you just get that for free. So we have customers that bought systems from us 3 years ago are now getting 50% more performance out of the exact same software that they bought 3 years ago because our development continues to get faster and faster over time. So all included in that subscription.
Yeah, and we don't charge for things like replication or any of the features. There's actually no extra feature charges.
And then second business question, what relationship, if you can talk about it, if any, do you have with public cloud providers in a business sense? If you're allowed to say it. Because this model appears to be handing AWS a nice egress revenue for data.
Sure. So we have a wide variety of customers using us in the cloud today. Some use some more cloud native where the data lives there 24/7, and we run active workloads on their behalf inside of AWS. In those models, instead of paying HPE for the underlying infrastructure, you're paying AWS for the underlying infrastructure. And instead of making a CapEx investment, you're making an OpEx investment.
I agree. So
yes.
you have a business relationship with HPE.
Yes.
OEM agreement. Do you have a similar relationship with AWS or Google?
To the extent that we're in the marketplace and available through them, and our software is optimized to run in those environments, yes. The way AWS goes to market, their sales teams are incented to sell whatever is in the best interest of their customer. Right. We work with those sales teams a lot, and oftentimes we are brought into opportunities by the AWS sales organization to solve specific problems for customers that Qumulo alone can solve.
This is meat in the field.
Pretty much.
Yeah, I think that's probably the best way to characterize
marketing.
it.
There's not a huge amount of investment, for example, from them. There are things that they've done to incent us to work with them, but it's not like they're a core investor or something like that.
There are other pieces of AWS, and I'm kind of going to walk up to a line and stop in this one because I don't want to. Yeah. Sure. There are other parts of the AWS business, some of which were announced at reInvent this past November, that we're in discussions with them to participate in.
Question about your platform. You've got there basically a split between on-premises and in cloud. Have you got any customers doing hybrid cloud implementations?
Sure.
So
yeah, we think about hybrid cloud in two different worlds. We call them corporate hybrid, meaning they have some workloads that run in the cloud and some workloads. And then we also have workload hybrid, meaning they burst for the power of being able to have elasticity of your compute is something that means a lot to lots of customers. And there's also certain services that are available by the cloud providers that the typical company running in the data center just can't afford to create in their data center, and through replication and other means, we allow them to move data up and back and forth between a cluster running on premise and a cluster running in the cloud.
So can that be done over the public internet, or does it require an MPLS connection?
You can do it over the public internet. You can create VPNs. You can use some of the cloud provider tools that help you do that.
You've got no real performance restriction.
You know, data comes with
Sure.
data. You know, physics are still involved in moving that up and down. So, but we're working with AWS in particular, and we've just started the same project with Google to more tightly integrate with some of the services that they provide for data movement to try and ease that, both in terms of cost and in terms of time.
So from a hybrid perspective, I pulled this back up just because this is a rendering use case where this customer is doing video rendering up in the cloud. They spoke at reInvent a few months ago. But in their environment, they needed to meet their deadlines. They needed about 1,000 nodes of compute to be able to render fast enough. They don't have the power, cooling, or data center space to do that, much less the equipment. So they literally went to Qumulo because they couldn't meet their deadlines and be competitive in their business if they couldn't burst to Amazon. So that's a customer in their public reference. We also see the hybrid use cases. If it's not for burst compute, it's typically because they want to run applications in the cloud that they don't have on-prem. So artificial intelligence specifically, they want to have access to the AI engines up in the cloud. Those applications that they want to have access to that they don't have on-prem, they put their data up there and they can do their work for those uses. So it's more for processing, more for application access that we see hybrid environments. We may see it more for just mixed storage, you know, an offsite store over time. But that's something that as we add in S3, we'll see kind of how customers use it on storage. So it's more an application and processing reason today.
And that story that Molly just told is one of the really powerful things of our view of the world of unstructured data. You shouldn't have to worry whether it's a file or an object. So you're trying to solve a new problem, and Google has just introduced a new AI capability that there's no way you would ever go create in your own data center. And you should be able to move a data set up into GCP and have it live as an object, have that data set be object-based and allow you to use their native tools, and at the same time run against that exact same data set the years and years that you've spent as a company developing your own tools for analyzing that data, which are probably in today's world file-based. So exact same data set, but you're able to use the power of the public cloud to do something against that data set and continue to use your file-based workloads. And that could happen in your data center. You could also have that data live up in, for this example, Google, and move it into object, into file, have it live in both, have it live in one, and have both access it. We give you that flexibility because that's what you want your storage company to do for you, is to give you that freedom and flexibility to run the workloads that you want where you want them.
Do you have any ideas about supporting customers with multiple public clouds and being able to move data between them?
Yeah, a lot of people talk about that. We obviously, the market that will ultimately emerge for file is multi-cloud access, which, because we are completely independent of the infrastructure, will allow you to do. There's nothing proprietary about what we do with the data when it's living in any of those public cloud providers. So you'll be able to move the data back and forth. Again, with the gravity that comes with that data, it's sometimes easier said than done in actually moving it around. But over time, we'll help develop. Today we've got replication to help you move data back and forth. You know, we'll get smarter and more efficient about helping you move the data sets to the cloud provider that you want when you want it there, so that you can run those workloads based on the cloud provider of your choice.
There's quite a bit of talk around now and for a little while now, actually. Maybe it's time to focus on moving the application rather than the data. As you say, data has gravity, applications typically have less. So is this something that you can cope with? Is it something that you think isn't necessary yet? You can still cope with the data movement?
So the application lives in the public cloud, or your data stays on premise? Is that
the concept is you move the application, not the data.
Sure. And in some workloads that will absolutely work. It just entirely depends how much latency you can absorb. The reason to have your data next to your application is to take latency out of the equation. So some applications just don't have the tolerance that you need. You can imagine a heavy I/O type of application is just not going to perform in that scenario. Some absolutely will.
We also have, it was an interesting use, one of our oil and gas customers that really wants to move to the cloud. That's a core tenet of what they want to take advantage of, the application, the flexibility of the cloud. They're going to move everything, except right now they're looking at their seismic processing data that's extremely HPC intensive. It's too expensive to move to the cloud. So you also find with applications, it's not just about storage, but running a huge HPC farm in the cloud, if you already own one on premise, it just doesn't make sense to them right now. So there's that piece too, of application to data, but also what is the cost of compute? Sometimes it's better in the cloud, sometimes it's not. So we see customers grappling with those types of things right now too.
Then one last point, and then you get into just the practical nature of the history of your company, whatever it might be. That same example that Molly just gave. Think about the 25 years of kind of Active Directory mess that they've created in their environment over time and trying to port that up. So working with them just to be able to integrate their data with all of their authentication and authorization tools becomes really, really complex. And especially now you start moving data around the globe, and they've got operations on every continent in the world, but their Active Directory environment doesn't have that same flexibility. And then you get into, again, latency types of things. So,
two small questions. First, you use some OEM, like IO, Tempo for data migration and so on. Why not going a step beyond and to have a kind of a marketplace or a Qumulo marketplace to offer this kind of OEM? Second, what is your roadmap or your intention to provide Qumulo as a microservices and containerize your storage services?
So on the application side, we're still a young enough company that we're partnering with Tempo for data migration, that customers need a good way to move data into our cluster. Tempo's really good at it. Us selling it isn't a huge value add to the customer as long as we work with them. It's just not a
not selling it, but to put it on a kind of a marketplace, because maybe one of your customers for one time will need this kind of service just to add it to use it. And
right now, we did negotiate some pricing with Tempo to make it accessible for the usage we have, where it's just kind of a one-time use, not the long-term data manager. So we have a good relationship with them. How they procure, they can do it in a couple of different ways, from a Tempo, from a our partner. We're a 100% channel company. That was the easiest way for right now. It was more of an enabler. We're not necessarily trying to get in the business right now. We're trying to stay focused on what we do and not get too worried about supporting other people's applications and software and taking those calls where we're not the experts. So it's just a company focused thing, and just trying to do a really good job at this right now is why. And the microservices, do you want to talk about that?
We have a very small team of people right now looking at containerizing Qumulo. It's R&D at this point, I think would be the fairest way to characterize it. There's no reason that we can't do it using Kubernetes or whatever we choose to use. It's just we don't have a huge signal from our customers today that that's something that they absolutely need, but we want to be ready when they are. So we're looking at it now.
So just to tie up, and we're getting a little short on time, and I want to make sure Joel has a chance to at least get into a cluster. A few things I want to mention. You can kind of see from general purpose file off to more video and rich media, we have a lot of adoption across the board. Some of the ones I think that are interesting is companies like Uber are using us as a replacement for HDFS. We're the only non-open source technology in Uber today that they buy it as an appliance because of the value of what our file system can offer to them. As you kind of go across and you look at some of these other areas, lots of biosciences, you're seeing genomics, medical research, MRI imaging, media and entertainment. FuseFX is the company we were talking about that was doing the burst rendering that needed 1,000 nodes of rendering up in the cloud. So a really broad adoption, and often it's business data as well as kind of business unit data that's getting married on the Qumulo system. And then just to tie up here, from a Gartner perspective, in 2016, we first hit their radar as a vendor to watch. By 2017, we had moved into the visionary quadrant. So when you think about this, they liked our vision, they liked what we were talking about what we were able to do. And we hit the customer revenue targets and the customer reference targets by 2018. And we'll move up. We're committed to that. So we moved extremely fast as a company into the leaders quadrant in the area of what we're doing. A few comments from our customers, and you can see these on Pure Insights. If you go up on Pure Insights and look at Qumulo, ideas of kind of what our story sounds too good to be true, but the reality was the hype, how easy it was to set up a petabyte of storage. Over here, that we're the partner in their business, the customer success I've been talking about, those are the things customers are calling out when they rate us on Pure Insights. And then as I hand this over to Joel, as of right now, 100% of our reviewers would recommend us to a friend. And I think that's kind of a big tribute to, they're super happy and they would tell their buddies in the industry that you should look at Qumulo. And we're really relying heavily on that, the references to continue to grow and show that our story is what we say it is. Customers are getting what we're marketing and they're really getting value out of it. So I'm going to hand this over to you, Joel, just so you can see a quick look at our screen with about the last 10 minutes so you can see a demo of what the technology looks like.
This is the UI that you use to manage your cluster. I would say, and we actually track this data pretty closely because we're very interested in it. About 2/3 of our customers use the UI in some fashion on a regular basis. Lots of our customers do it entirely programmatically through command line and or API calls. But we do have this HTML5 UI that people can use on whatever platform that they want to manage. This is the dashboard that gives you just a high-level overview of what's happening on the cluster. You can see that in the last 24 hours or so, I can take a quick look at what's happening on the cluster. If you see of anything of particular interest, the reason I went over here is I wanted to, if you want to see what's happening at a given time, you can just go right there and then look at the different I/O that's happening. You can filter out reads and writes if that's something that you're interested in. You can see, So here's, so now we talked a lot about our real-time analytics. And this is, again, we have aggregates built into the file system. So without any third-party process actually managing this, this is all reported internal to the file system. And I can look and see what's happening on the cluster. You can see by this color coding here what I'm actually seeing. So I just, with a quick view of the cluster, this is a graphical representation of the cluster. I can see that most of the I/O is happening down here in this particular directory. And then I can look and see which clients, so these are IP addresses of the clients that are hitting it, what they're generating, and then also which paths are most active on the cluster right now. And that's all inside of this given directory. If I want to look at a different directory, I can go there and I see a completely different set of data. If I want to go a little bit deeper, we have these Sankey diagrams that show just the I/O on the cluster. And again, this is scanning of the entire file system. This is true whether there is 1,000 or 1 billion files in the file system. We give you a look at hotspots. So this will actually show you that This is the activity happening at any given time in the cluster, and you can actually see the paths that are driving most of. This is a view of the throughput on the cluster. If I want to turn and look at the IOPS on the cluster, I get a completely different view based on the IOPS on the cluster. And this is all updated in real time. If I'm primarily interested in what's happening from a capacity standpoint, I can look at my cluster and I can, again, given the API, you can look at whatever time period you want based on a variable. In the UI, we give you 3 options: during the last year, the last month, or the last 72 hours. If we look at what's happened in the last 30 days, I can scroll over and see that there have been a little bit of activity in these days, and in some days it kind of jumps up. And then we had a day where a bunch of data was deleted, which might be interesting from one perspective, but that doesn't really give you anything actionable. What we can do, though, and I think I'm going to lose it because I don't have internet access anymore, is this would provide the actual information of the file paths that were deleted. So you could instantly go into the file system and see that on this date, which is the 21st of this month, during that 24-hour period, there was a net change of almost 5 terabytes deleted, and you would see the paths where those files were deleted from. So in terms of answering questions about your data and getting you out of the information of what's happening from a storage perspective and asking the high-value questions about what's happening with my data, this is one of the tools that allows you to do that. From just a feature standpoint, you get real-time quotas, and now the internet is completely gone, and I'm not even going to be able to move through the UI. So that's a little bit disappointing, but
quickly log in.
Joel,
Yes.
are you on the Ferndale?
Yes,
Internet?
I am. I can, let me see if maybe it will come back if I
Turn it off and turn it on again.
Mm-hmm. What would we do without Control-Alt-Delete? All right, so let's see if we're back. Aha. Okay. So, we talked about these things. I'll just to verify this. If I go here now, you'll be able to see the paths instantly that were deleted or added at any given time frame by just clicking on it, and it will bring up that information.
So you can see this as predictive, compliance reasons. There's a variety of reasons customers find this extremely valuable.
Let me see if just real quickly in the background, it takes about 90 seconds or so to spin up a cluster. So let me see if I'll need to log in again. I apologize. So I'm going to kick off the creation of a cluster. Again, I'm going to do this in the UI just so you can see it, but most of our customers do this completely using our APIs. So I'm going to just use a CloudFormation template, which is a native Python script or JSON from AWS, and we'll quickly pick.
From a POC perspective, this is a really great tool where customers can go up here and spin up small instance, use it themselves without having to get hardware shipped, get that approved by Qumulo. So customers get experience with Qumulo very easily up in the cloud, even if they're going to later do an on-premise purchase.
Okay, let's see. We'll just quickly get some things spun up here. I'm basically just putting in some parameters that you would do over with the APIs. we'll skip all of the options and we'll just get this thing launched. You'll see that it's creating the cluster. It'll take somewhere between 60 and 90 seconds. So while that's happening, we'll go through and just talk about real-time quotas where you can create them. Because we have this aggregates built into the file system, hard quotas are managed instantly. You don't send it off to a job queue to manage. When you hit your write limit, you are stopped mid-write if needed, because we're constantly monitoring all activity on the cluster. As you would expect, the major file protocols. The way MinIO works, if people are interested, is it actually mounts to Qumulo over NFS and then exposes an S3 interface out to the application for those people that want to do that. As I said, we are working on building our own native S3 interface as well, but today we offer that to our customers. You get full AD and LDAP connectivity, and then you can dive in and look at snapshots, create replication relationships, and then quickly, if we look at the tools, let's go back here and see where we are. And our cluster has now already been created. So I've just created a cluster in AWS while we were doing that. This is the master node of the cluster. We created a 4-node cluster. We could have created whatever size we wanted, of both quantity of nodes and size of each node. This is a moderate size for our customers. This is 5 terabytes per node. We have customers that create all-flash nodes that are like 500 gigs each. So you get very high performance at very low capacity for certain workloads that they want to run. And we make all of that true for them. And I think the only thing that I'll show you here is that you're going to get the exact same. And because it's not entirely, we create a temporary password just for security, and it's the instance ID of the master node. So we just provide that to you in the output, so you can just copy and paste it into the cluster.
We have a couple of minutes left.
Okay.
So I get the only point here is if you look at this UI, which is the actual one running in a data center in Seattle, Washington, and this UI, which I just spun up in AWS, it is the exact same UI with all of the exact same features. So it is in fact the same software, which gives you that ability to move data back and forth. You get data coherency. If we go back to the FuseFX example, one of the powerful things for them in using Qumulo is if they do a render job in their data center and they do a render job inside of AWS, they get the exact same frames from that because everything is identical. So they talk about data coherency, meaning they don't have to go in and do a bunch of color correction or anything after the fact because it's being served up identically by both systems. And in the couple of seconds I have remaining, we'll just quickly talk about the APIs, I hope. So a couple of things, and we won't have time to go into a lot of the actual APIs, but just by logging in over the APIs, you'll see a couple of things. We give you the JSON output, so for people who are actually building scripts, we just hand you the JSON that you can add directly into your script. As a company, we build from an engineering perspective, we always talk about API first. So the very first thing that an engineering team will do is build the APIs, and then the UI that I just showed you is just built on top of our API set. So all of the things that I just did and lots more, all done through API calls, and all of these things are just very basic API commands that you can use to do whatever you need to do about managing your cluster. So creating a cluster, tearing one down, checking on its cluster settings, getting the configuration. These are all just simple API commands that we provide you. This is a tool called IO Docs, which is basically self-documenting technology just to make your life easier as a developer as you start to integrate Qumulo into your regular workflow. And then you can read and write over these APIs. So the oil and gas customer that Molly referenced, we help them move data back and forth between their Qumulo clusters, which are now spread across the globe, and their S3 buckets, and basically they're using this API in conjunction with the native S3 APIs inside of AWS to actually move the data back and forth between those two worlds and access the data sometimes over S3, and other times they need to migrate tools that they've got 20 plus years of experience using, and they access those over NFS or SMB. So
there's kind of like API translation going on from yours to AWS.
Yeah, they wrote a very simple little Python script that does the translation. It's not highly performant, but because they've got a lot of monitoring tools in place to make sure that the data is where they want it to be when they want it to be there, they have the luxury of time to move that data back and forth. Whereas the native S3 integration that we're building will do it at a much higher performance rate.